Okay, so now we're going to do some proofs with these properties. So for the first proof, it says that triangle MJK is congruent to KLM. So we're already given congruent triangles, and we're trying to prove that this is a parallelogram. So the first thing we need to know is that if we're given congruent triangles, right away you should think to use CPCTC. And that's because if you're given congruent triangles, then you should use those congruent triangles. So you should use the fact that if the whole triangle is congruent to the other whole triangle, then any of their parts are going to be congruent. So remember that CPCTC, when I say corresponding parts, I'm talking about angles or sides, right? So we're going to have to prove something about angles or sides congruent. And so if we look at how we're trying to prove that this is a parallelogram, I kind of like this reason here, or possibly this reason here. So proving either sides or angles are congruent. If we could do that, then we could prove this a parallelogram. Now remember, we only need two pairs of angles or sides. So I can't really use angles here, and that's because if I prove, for example, angle J is congruent to angle L, that could be helpful, right? But we wouldn't know anything about angle M and K because which angle M are you talking about, right? Angle M or JML is not part of one specific triangle. So I am going to take this off the list of things that I could be using, and I'm going to go the route of opposite sides are congruent. So now, how am I going to do that? Well, which sides are congruent? So the first set of sides that are congruent are JK and ML. And that is because JK from this triangle is in the same spot as LM in this triangle, right, or ML. And so they're corresponding parts of congruent triangles, CPCTC. So JK and ML. So now, using CPCTC, what's another step that I can say for step 3? So if I already know that JK is congruent to ML, what else could I say using CPCTC? So you could say that JM is congruent to KL for the same reason, CPCTC. So now, if I look at this entire parallelogram here, we already have enough information to prove that it is, in fact, a parallelogram because their opposite sides are congruent. So here we could say that MJKL is a parallelogram, and the reason would be opposite sides of a parallelogram are congruent. And that's it. For the next proof, we are given that triangle AED is congruent to triangle CEB. So now, again, we're given congruent triangles. So I'm most likely going to be using CPCTC. And I'm going to highlight the triangles that are actually congruent. So it's AED, so it's this. Oh, let me highlight. No. So AED and CEB, so that's CEB is here. Okay, so it's these two triangles I know are congruent. Okay, so Now let's think about which proof reason we are going to try and use for this. Well, I have diagonals. Normally, if diagonals are drawn in the diagram, then you're going to want to try and use them. So if you see diagonals are drawn, try using them. Okay, so how would we use these? Well, we would need to be able to know that they're bisecting each other, right? So we would need to know that AE is congruent to EC. And we can actually say that in step 2. So in step 2, I could say AE is congruent to EC. And so why can we say that? Because we don't know yet that the diagonals are bisecting each other because we don't know that this is a parallelogram yet. But what allows me to say that AE is in fact congruent to EC? That would be CPCTC, because these are corresponding parts of congruent triangles. How did I know the triangles were congruent? Because we were given that they were congruent. Okay, so you could do the same thing with DE and EB. For the same reason, CPCTC. Okay, and so now we have markings showing that the diagonals are bisecting each other. Yay! So we've accomplished this. So now that we've accomplished what we need to accomplish, now I can say that A, B, C, D is a parallelogram. And I know that because, well, the diagonals of a parallelogram bisect each other. So if they bisect each other, then of course it has to be a parallelogram. Last proof that we're going to do in example 3, we're given that angle ABD. So ABD, if you trace that angle out, it's this angle here. So ABD is going to be congruent to angle CDB. So that's this angle here. So these two angles are congruent. We also know that AB is congruent to DC. So we're given all of that. Okay, now I already have one pair of sides that are congruent. So there's 2 different routes that you can go with this proof. You can go the CPCTC route again, or we could try something different. So let's look at all the other proof reasons that we haven't used yet. So consecutive angles of a parallelogram are supplementary. We're not really going to be using this much to prove parallelograms. But opposite angles are congruent. Could we prove something about the opposite angles? Well, we could prove something about A and C, but not B and D, because B and D are split, right? What about one pair of opposite sides are congruent and parallel? AB and DC are already congruent. Can I also already say that they're parallel? So if I say AB is parallel to DC, what do you think the reason would be in order to prove that AB is parallel to DC? So what would allow me to prove right away that these 2 segments are parallel? Okay, so that proof reason would be that alternate interior angles are congruent. So that's going to imply parallel lines. So the alternate interior angles were congruent, which implies that the lines are parallel. Okay, so now I have one pair of opposite sides that are both parallel and congruent, which is enough to prove that these two triangles are, or sorry, that this parallelogram or this quadrilateral is a parallelogram. So step 3, I can just say ABCD is a parallelogram, and the reason would be one pair, opposite sides are both congruent and parallel. And that's it.